In this video, we're going to solve some quadratic functions using the quadratic formula and notice and observe some connections between the quadratic formula and the number of solutions that are present for the quadratic function. Let's start with the first quadratic function, x squared minus 4 equals 0. Our a value is 1, our b value is 0, and our c value is negative 4. We plug into the quadratic formula. X equals negative b, so negative 0, plus or minus the square root of 0 squared, b squared, minus 4 times a times c, minus 4 times 1 times negative 4, all over 2a, all over 2 times 1. So then we have x equals negative 0, just 0, plus or minus the square root of 0 squared, which is 0. I'm going to go ahead and make that minus 4 a plus negative 4 times 1 times negative 4. So we end up with positive 16 inside the radical, all over 2. So x equals 0 plus or minus the square root of 16 all over 2, which is 0 plus or minus 4 all over 2. We can separate this into two values, the one given by 0 plus 4 over 2, and the one given by 0 minus 4 over 2. 0 plus 4 over 2 is 4 over 2, or just 2, and 0 minus 4 over 2 is negative 4 over 2, or negative 2. Notice how we ended up with two distinct x values. That means there are two real solutions for this quadratic function. If we were to graph this quadratic function, it would cross the x-axis at negative 2 and positive 2, our two solutions. Taking a look at the a value, we see that it's 1, or positive, so it's an upward-facing quadratic. Two real solutions results in two x-intercepts, so the graph is going to cross in two places. And we ended up with those two solutions because when we had plus or minus, there was an actual number after it. It's separated into two different numbers, two different solutions. Let's take a look at the next example. X squared minus 2x plus 1 equals 0. Our a value is 1, our b value is negative 2, and our c value is 1. Plugging into the quadratic formula, we end up with x equals negative b, negative negative 2, which is 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a times c, so minus 4 times 1 times 1, all over 2a, so all over 2 times 1. We simplify, so we have x equals 2 plus or minus the square root of 4 minus 4 all over 2, or x equals 2 plus or minus the square root of 0 over 2, or 2 plus or minus 0 over 2. When we separate this one into the two solutions, we get 2 plus 0 over 2 and 2 minus 0 over 2. We actually end up with the exact same x value of 1. This is what's called a repeated root, so there's really only one real solution, only one distinct, unique solution. When we graph it, since it's a repeated root, our graph is going to touch the x-axis at 1, its solution, but it won't go through the x-axis, it'll bounce off, which means that the 1 is going to be the vertex. Notice that your a value is positive, so again, this is an upward-facing quadratic. Let's take a look at the last one now. So our a value is 1, our b value is 0, and our c value is 4. This is a lot like our first example. So we have x equals 0 squared, negative 0, plus or minus the square root of 0 squared minus 4 times a times c, 4 times 1 times 4, all over 2a, 2 times 1. The only difference is the sign change of the 4. So we end up with 0 plus or minus 0 minus 16 on the inside, all over 2. Or 0 plus or minus the square root of negative 16 over 2. We actually can't square root a negative number and end up with a real solution. It's an imaginary number. Therefore, we say that this one has no real solutions. If we were to graph it, that means that the graph of it cannot cross the x-axis at any places. There's no x-intercepts. Taking a look at the a value, we see that it's positive, and therefore we know that our quadratic function is going to be an upward-facing graph above the x-axis, so it won't ever cross the x-axis. If our a value had been negative, then our quadratic function would have had a graph that was downward-facing below the x-axis. Notice that we end up with no solutions whenever we have a negative discriminant when it's underneath the square root is negative, because it results in imaginary solutions. We have one real solution when the discriminant is 0, or what's underneath the radical is nothing, because we're adding and subtracting 0. It gives us two of the same solution. And we end up with two real solutions whenever we have a radicand, or what's under the radical, is positive, because when we do plus or minus, it ends up with two unique real solutions. Hopefully this helped to connect together the quadratic formula with the discriminant and the number of solutions that a quadratic will have. Thanks for watching.